Good afternoon, dual credit pre-cal students. Today's lesson is section 6.7, and this section is about the dot product, which is one of the operations that we can use with vectors, that we can perform with vectors. And it does have a pretty interesting significance. So let's get with what is the dot product first, and we have it defined, as you can see here. And remember from our previous lesson, we mentioned how A represents the horizontal components and B represents the vertical components. So in this case, for the dot product, B dot W, we're going to multiply the horizontal components, so 5 times -3. And then we're going to add the product of the vertical components. So that will be -2 times 4. And so for that one, the answer will become -15 minus 8. And so that is -23. And that is C. So the dot product is one number and one number only. Okay, so I'm going to solve the next part B. And so for part B, and it's probably important that I write down what I was looking for. So the first one, it was B dot W. And so that one, we said it was 5 times -3 plus -2 times 4. Okay, now for the next one, we're going to find W dot V, and for that one, we take the horizontal component of W, which is -3, and multiply it by times the horizontal component of V, and that would be +5. And then we add the vertical component of W, which is +4, times the vertical component of V, which is -2. And so here we can see that -3 times 5 is -15, and 4 times -2 is -8. So what we get is also -23. And you guys can see that we do get the same number. So what I'm going to say is that dot product is commutative. So that means we could change the order of the vectors, and you will get the same result. Some professors refer to performing the operation of, or finding the dot product, they call it dotted. So they could say that something like this will be vector B dotted with W. I don't know if that is actually a real term, but that's how they call it. Now, we could also do a dot product of one vector to itself. And so for that one, we will do the same thing. Take the horizontal component of vector B, which is +5, so here. And so it will be 5 times 5 plus the vertical component, -2 times -2. In other words, you're doing 5 squared plus -2 squared. So that will be 25 plus 4, and so that equals to 29. And so that is the answer for part C. So let's go to the next slide. And the next slide, we have some properties that we're going to go over briefly. And as you guys could see, we have the first one, which it is the commutative property. The second one, that is the distributive property, and that means that if you're adding two vectors and you want to dot one vector times the sum of the other two, you could distribute that one by doing the dot product of U dotted with V, and then similarly the dot product of U dotted with W. And so this one is a representation of the distributive property. And of course, we talked about the zero vector. So if you dot the zero vector with any vector, you will obtain a constant equaling 0. Also, when you dot a vector with itself, you obtain is the same as squaring the magnitude. And finally, we have that if you multiply a scalar times a vector and then you dot it with another vector, will be the same thing as doing the dot product of the two vectors first and then multiplying by the scalar, which in this case is c. Also, you could do, in this case, we're multiplying the scalar times u, and then here we're multiplying the scalar times v. So either way, you will obtain the same result. What I'm going to do next is we're going to work with a formula. And so we're going to derive this formula. And please pay attention. You do need to take notes. And I'm probably going to give you guys a quiz when I come back on Tuesday on this proof. So I want all of you guys to pay attention. And so I know it's very small on your paper. So I'm going to make this little image a little bigger. Okay, and so hopefully you can see a little better. But what we're going to be using is the law of cosines. And so that's what I have written here, law of cosines. And so that one, if you remember, it goes like this. So a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So that is how we used to use it back in section 6.2. Now that we're in section 6.7, we're going to use it to find what are we finding? Oh, to find the magnitude of u. That's what we're using it for. So let's get started. And so what we already have here is the distance formula. And considering that vector u goes from here to here, so to write down that vector in terms of I and j, we use the following. And as you can see, they took the difference of the horizontal components and the difference of the vertical components. Now to find the magnitude, what happened here is the same as applying Pythagorean theorem. So they're squaring this or distance formula, whatever way you want to see it. And so that's what's written there. Now let's look at the other vector, and this will be vector b. And so this is the initial point at the origin. And here is the terminal point. So the coordinates here are 0, 0, and here we will use a sub 1, b sub 1. So to write that vector in terms of I and j, since the initial point is at the origin, then we could just use the Pythagorean theorem. And I'm sorry, it would just be a sub 1 for the horizontal component, b sub 1 for the vertical component. And to find the magnitude, we could just use Pythagorean theorem. That would be fine. Now the third vector in question here is vector w, and so that one starts here and it ends here. And so for vector w, we also have the coordinates 0, 0, and then a sub 2, b sub 2. So here, in terms of I and j, it will just be a sub 2 for the horizontal component, b sub 2 for the vertical component. And the magnitude could be found very easily by applying the Pythagorean theorem. Okay, so now what I'm going to do next is I'm going to use those statements, and we're going to use the formula that we have here. So I'm going to go ahead and write it down first. So that will be the magnitude of vector u squared is equal to the magnitude of vector b squared plus the magnitude of vector w squared minus 2 the magnitude of b times the magnitude of w times the cosine of theta. Okay, so what I'm going to do is substitute the magnitudes with the statements that we have here, with those three statements. So the first one for the magnitude of W, and you guys notice it is being squared. So what will happen if I square a square root? And I think you can all tell me that that will cancel the square root, right? So because of that, I don't need to write down the square root anymore because I'm squaring the magnitude. So then I just need to write a sub 1 minus a sub 2 square, and I'm taking that from here, plus b sub 1 square minus b sub 2. Sorry, I made a mistake. Go back. So it is b sub 1 minus b sub 2, and then square outside the parentheses. So that covers this part. Then we need the equal sign. Now we need the magnitude of b squared. So we're talking about this one. And you already know that if we square a square root, it will cancel the square root. So we will need a sub 1 squared plus b sub 1 squared. And I was referring to those quantities there. So that took care of this part. Now the next thing is the magnitude of w squared. So I'm going to be using the what's inside that radical. And so since it is being squared, again, if you square a square root, what happens? It cancels the square root, correct? So then we will have plus a sub 2 squared plus b sub 2 squared. That takes care of this part right here. Now we also need minus 2 times the magnitude of b, which is a sub 1 squared plus b sub 1 squared, this quantity here, times the magnitude of w. Oh, actually, I'm sorry. I don't need to write that down. Let's just leave it expressed with the notation for magnitude. Okay, so far that's all I needed to do. Now what I'm going to do is expand the left side. And so here, remember that I have something like that binomial times itself. So what I'm saying is that I have a sub 1 minus a sub 2 times a sub 1 minus a sub 2. And so when I do that, I'm going to end up with a trinomial. And so that trinomial will be a sub 1 squared minus twice the product of the first term times the second. So that will be minus 2 a sub 1 a sub 2. And then plus a sub 2 squared. We also have, from this one, we're going to obtain the trinomial b sub 1 squared minus twice the product of b sub 1 times b sub 2 plus b sub 2 squared. That takes care of the left side, and now for the right side, I'm just going to write everything that is still there. If you need Mr. Marshall to pause the video, let him know. Now what I'm going to do is cancel things that appear on both sides, on the left and the right. And the idea behind there is that if I subtract a sub 1 squared here and also here, I'll be able to cancel them, right? So as long as you have them on both sides, you could do that. And so we see that we have a sub 1 squared. We also have a sub 2 squared on both sides. We also have b sub 1 squared on both sides. And finally, we have b sub 2 squared on both sides. And that's it. That's all we can cancel. So now let's see what we have left now. So what we have is negative 2 a sub 1 a sub 2 minus 2 b sub 1 b sub 2. And that is equal to minus 2 times the magnitude of b times the magnitude of w times the cosine of theta. And so here, what I'm going to do is I can divide by negative 2 on both sides. And if I do that, that is going to take care of the sign. I'm sorry, the -2. And so I don't want to get you confused here. So divide by -2, divide by -2, divide by -2. And so we do that, and we can see the -2's are going to cancel. And so we have, because they equal to 1, so we're left with a sub 1, a sub 2, minus b sub 1, b sub 2, and that is equal to the magnitude of b times the magnitude of w times the cosine of theta. Okay, and let's see. Oh, and I made a little mistake. What happens when I divide -2 divided by -2? And that should be +1. So this should be positive. Okay, now just to finish it up, I want to remind you what we did at the very beginning of this video, and that was look at the definition for dot product. And I believe it's on the other slide. And so if we look at it here, we could see that a sub 1 times a sub 2 plus b sub 1 times b sub 2 is the definition for the dot product. And so that's what I'm going to say. I'm going to go back to the second slide. And so all the work that we did was just to arrive to that conclusion, that here we have the same as the dot product of v times w. This expression. And so here we have still magnitude of v times magnitude of w times the cosine of theta. All right, and from there, it's going to take us to the next slide. And so that formula right there is what we call the alternative formula for the dot product. And remember that we were able to figure out, because after all those computations, we found that that was okay, and we were able to find that because here, after doing all that work, we found out that the left side was equal to a sub 1 times a sub 2 plus b sub 1 times b sub 2, and so that was the definition for the dot product. Okay, so this is a formula that we're going to be using, and we're also going to use it to derive other formulas. And so yeah, I know, more formulas to memorize. And so what we have here is the alternative formula, and I want you guys to solve for cosine here. And so you can see that the magnitude of v and the magnitude of w are both multiplying to cosine. So I am pretty sure that you know what to do. So you need to do the inverse operation of multiplication. And so all of you guys know that is division. So we're going to take the magnitudes and move them across, and since they're multiplying on the right side, once you move them across, they will be dividing. Okay, so now from there, I want you guys to solve for theta. And so to solve for theta, we have to take, if we have cosine of theta, we take the inverse of cosine, and of course that is cosine inverse. Okay. And so that will also be a formula that we will be using, and in fact you could see it at the bottom of your slide. So we have here the formula to find the angle between two vectors. It is, you could use the cosine, and remember this formula came from deriving the alternative formula for dot product. And if you solve for theta, that will be taking the cosine inverse of the dot product of B times W divided by the magnitude of B times the magnitude of W. Okay, so we're going to go to the next slide. And here we're going to find the angle between two vectors. And so the formula that we're going to be using, remember, it comes from the alternative formula for the dot product. And so that one, actually I'm going to write it down here so you guys can get a little familiar with it. So that formula was the dot product is equal to the magnitude of B times the magnitude of W times the cosine of theta. So now to solve for the cosine of theta, it will be the dot product of B times W divided by the magnitude of B times the magnitude of W. Okay, so now let's see what we do know. And we know that the cosine of theta, the dot product between B and W, remember that one was given by multiplying the horizontal components. So that will be this part right here. It will be 3 times -1. And then plus the product of the vertical components, or the J component. So that will be -2 from here times +4. Okay, so also we need to find the magnitudes of both vectors. So let's go ahead and do that here on this side. So the magnitude of B is going to be, by using Pythagorean theorem, it will be 3 squared plus -2 squared. So that gives me 9 plus 4, which is the square root of 13. Also, let's go ahead and find the magnitude of W. And so by using Pythagorean theorem again, we take the -1, square it, plus 4, and square it. And so that will give us 1 plus 16 inside the radical. So that means we have the square root of 17. Okay. So now that I know those two quantities, I can replace the magnitude of vector B with the square root of 13. And I can replace the magnitude of W with the square root of 17. Okay, and we're almost done. So here the cosine of theta is going to equal to, I'm going to give you guys a simplified version, and that will be -11 divided by the square root of 221. And the reason I got 221 is by multiplying 13 times 17. When you multiply radicals, you could go ahead and multiply inside the radical sign. Now from here, we're looking for theta, now for the cosine of theta. But of course, you guys know how to find theta. And so that one will be found by taking the cosine inverse of this quantity here. And so it will be -11 divided by the square root of 221. And so I'm going to give you guys a little an approximation. And so what I got was 100, and if you guys notice, it says round your answer to the nearest tenth of a degree. So that will be 1 digit after the decimal point. So that will be 137.7 degrees. Okay. So I'm going to leave checkpoint 2 for you to work on your own. And just so you know, the answer for that one, it will be 100.3 degrees. And you can work that at home, or you could, but you will get enough practice with the homework. Okay, let's go to the next slide. And we're going to write a couple of definitions. And we will stop the video after this slide, the part 1, and then I'm going to record part 2 at a later time, but you will watch both parts today, Thursday. So two vectors are parallel when the angle the vectors is 0 degrees or 180 degrees. And we have an example here with 0 degrees, and we know that because they are going in the same direction. Now, when they go and I know it's kind of weird to say that they are parallel, but they are parallel, just because of the degree between, the angle between them. And so if they're going opposite directions, like the case of this one, then that's because the angle between them is 180, which is a straight angle. Okay, so if the angle between the two vectors is equal to 180, we could say that then the vectors point in the opposite direction. Okay, and so we have one last statement here, and we have a new word, and that word is orthogonal. And so that word is used to imply perpendicular vectors. So instead of saying two vectors are perpendicular, we would say two vectors are orthogonal. And so that will happen when the angle between the vectors is equal to 90 degrees. And so we have an example here of two orthogonal vectors, and we are not assuming the angle is 90. We know that, and also we can see that little box, right? So we know for sure it is 90. Now, let's see how we could use the dot product to determine if two vectors are orthogonal to each other or perpendicular to each other. And so what we're going to do is go by this definition, and it says that two non-zero vectors, and we have to specify that they are non-zero because any vector times the zero vector, any vector dotted with a zero vector will get a dot product of 0. So that's why we're specifying, like we're talking about vectors other than the 0 vector. But it is safe also to say that the 0 vector is orthogonal to every vector, okay? So now let's pretend we don't have the 0 vector there. So for two vectors to be orthogonal, let's call them V and W, that will only happen, and notice how here we have the if and only if. So that is that I with a double F or the double arrow. I know you guys taken geometry have seen that. And so that will happen whenever the dot product of those two vectors in question is equal to 0. And that is the only way that they will be perpendicular or orthogonal. So let's go ahead and answer problem 3, example 3. And we're going to check if the vectors V and W are orthogonal. So we're going to go ahead and compute the dot product. And in this case, we're going to use the easy formula to find the dot product. And so that will be 6 multiply the horizontal component, 6 times 1. And the reason I'm multiplying by 1 is because 1 is the coefficient of the horizontal component. So 6 times 1 plus the product of the vertical components, negative 3 times 2. And we get 6 times 1 is 6, negative 3 times 2 is negative 6. So we have 6 minus 6 is 0. So we can say that the dot product of V dotted with W is equal to 0. Also, you could see it from the graph. Here's one vector, here's the other, and you could see the 90-degree angle. If you were not sure, there's another way to find it, and if you think about direction, remember how we mentioned that magnitude, you use Pythagorean theorem. For direction, you use slope. And so the slopes of two perpendicular lines, so L1 and L2 are perpendicular if the product of their slopes is equal to -1, or if the slopes are negative reciprocals of each other. Same thing. So that's another way that you could check if the vectors are perpendicular, but we're going to stick to this method by using the dot product. Okay, so I'm going to stop the part 1 of this video now.